Have you ever really stopped to wonder how your phone knows that a picture you just took is a cat? Or how your favorite streaming service just seems to read your mind? Well, the magic behind all of that is something called an artificial neural network. And today we are going to pull back the curtain and demystify this incredible engine of modern AI.
I mean, really, think about it. How does that little device in your pocket instantly nail it? Yep, that's a cat. Or how does a streaming service seem to know exactly what movie you're in the mood for? The answer to both questions is a piece of technology that is, well, quietly reshaping pretty much everything around us. And that's the neural network.
Okay, so what in the world is an artificial neural network, or ANN for short? Well, at its very core, it's a computational model that's inspired by the most complex, most amazing machine we know of, the human brain. The best way to picture it is like a giant digital web of interconnected neurons that all works together to process information, kind of like the ones that are firing in your own brain this very second.
All right, brain-inspired. That's a pretty cool term, right? But what does it actually mean when we talk about a computer? Let's dive in and break down that powerful idea. See, at its heart, a neural network is a bold attempt to mimic how our own brains learn. So instead of a programmer writing a strict, step-by-step list of commands like, if this, then that, the whole point here is to build a system that can actually learn on its own. It's all about recognizing complex patterns and adapting from experience, just like you and I do, using this network of interconnected digital neurons. So, if we're going to build a digital brain, what are the pieces? What are the fundamental building blocks? Let's take a look at the basic anatomy of one of these things. Okay, so instead of gooey biological cells, ANNs use artificial neurons. And really, all these are simple little nodes. Think of each one as a tiny little decision maker. It gets some signals from its neighbors, it does a little bit of math on them, and then it decides whether to pass a new signal on to the next guys in the line. That's it. And all this information flows through the network in a really organized way, in layers. First up, you've got the input layer. This is where the raw data comes in. Think of it like all the individual pixels of that cat photo. Then that data flows into the hidden layers. This is where the real thinking happens. The signals get processed, transformed, and analyzed. And finally, you get to the output layer, which spits out the final answer. Something simple like cat or, well, not cat. But wait a minute, how does it actually learn what a cat looks like? Well, the secret sauce is something called weights. You can think of a weight as a number that tells the network how strong or important a connection between two neurons is. It's like a volume knob. And believe it or not, the entire learning process is basically just the network carefully adjusting millions of these little knobs, tweaking them over and over until it consistently gets the right answer. And that brings us to the absolute core of how these networks get so incredibly smart. It's actually a very human idea. They learn from their mistakes. And this whole process is called training. All right, let's make this really concrete with an example. Imagine we show the network a picture of a sea urchin. Now, based on the weights it has right now, it might look at that spiky, ringed texture and guess, that's a starfish. Then we, the trainers, tell it, nope, sorry, that's actually a sea urchin. The network now has a crucial piece of information. It knows it messed up. And that's it. That is the entire goal of training, to shrink that error, to close the gap between the network's guess and the correct answer. And it does this over and over with thousands, even millions of examples, getting just a little bit closer to the truth each time. So how does it do that? Well, the main tool is a really clever algorithm with a fancy name, backpropagation. Don't worry about the name. All it does is work backward from the mistake. It's kind of like a coach reviewing the game tape after a bad play. The algorithm goes back to every single connection and says, okay, you need to adjust your weight up a little bit, and you need to adjust yours down. It's this tiny, systematic course correction, but it's repeated millions of times. Now, I know this all sounds incredibly futuristic, right? But what's wild is that the core ideas have actually been floating around for decades. So to really get a handle on where we are today, we got to take a super quick trip back in time and look at the breakthroughs that paved the way. Okay, the story really kicks off way back in 1958 with something called the perceptron, one of the very first stabs at an artificial neural network. Then, fast forward to 1970, and the modern version of that crucial backpropagation algorithm gets published. In the 80s, we see the neocognitron, which was a major precursor to the networks that recognize images today. But the real game changer, the moment that sparks the AI revolution we're living in, was 2012. A network called AlexNet just absolutely crushed a major image recognition competition, and the deep learning boom began. All right, so that's the history. Let's jump back to the here and now. How is all this brain-inspired tech actually showing up in our daily lives? Well, the simple truth is neural networks are not a sci-fi concept anymore. Not at all. They are the quiet, invisible engine running in the background of so many of the things you use literally every single day. I mean, they're the reason your phone can unlock just by seeing your face and why your voice assistant actually understands what you're asking. They're powering those amazing translation apps and the chatbots you talk to for customer service. They're even at work in finance, spotting fraud, and in hospitals, helping doctors with medical diagnoses. And now they're even getting into the creative space, generating art, music, and text. But with all of this incredible power, and it is incredible, comes a really serious and complex challenge. And that challenge is bias. So here's the critical issue, the real catch. A neural network is only as good or as fair as the data we train it on. It's the classic idea of garbage in, garbage out. So if we feed these systems data that already contains our own human societal biases, well, the network won't just learn those biases, it can actually amplify them. And this is not theoretical, it has very real consequences. Take this example from 2018. Amazon had to completely scrap an AI recruiting tool they'd built. Why? Because it was found to be biased against women. It was actively penalizing resumes that had the word women's in them, like captain of the women's chess club. The reason was simple. It had been trained on 10 years of hiring data from a male-dominated industry. The AI didn't learn how to find the best candidate, it just learned to repeat the hiring patterns of the past. And that really leaves us with the biggest, most important question we have to face as we build out this technology. If AI learns from our data, from the world we've already created, how do we make sure we teach it our values and not just our flaws? That is the great challenge that lies ahead.